Hello, this is problem 875, Integrated Math 3. You're given some polynomials in factored form and asked to find all of the roots. This is a third degree polynomial. I can tell that it's a third degree polynomial based on the fact that there's an x squared term in this factor. It's a quadratic factor, and then times the other linear factor, I'll have a 5x cubed. And because that a value is 5, again, the a value is 5, which is greater than 0, I know that this cubic will start and end. Again, it will start and end in this fashion right here, where it's starting in the negative and ending in the positive. Because of those two clues. Now, having to find the roots is our goal for all of these problems. And so here I can see that one of the roots, being the x value that makes this linear factor 0, would be an x value of -1. And to find the remaining factors, I've got to think about this quadratic factor. What are the roots of the quadratic factor? And so looking at that 5, I immediately think, well, can I factor it? So 5 times 1 is 5, but there are no factors of 5 that will sum to a 1. And I'm not going to complete the square because the leading coefficient is 5, and I would have to divide everything through by 5. So instead, I'm going to use quadratic formula to figure out when is 5x squared plus x plus 1 equal to 0. And so using quadratic formula, I would end up having x equals negative b plus or minus radical b squared minus 4ac all over 2a. Simplifying this a little bit, I end up with a -1 plus or minus the square root of 1 minus 20, which is a -19 underneath the radicand, and so, or the radical symbol, and so this is then over 10. And so simplifying this a little bit, it's -1 plus or minus I square roots of 19 all over 10. And so that is the other, conjugate pair or complex conjugate pair that are the roots. Only these roots are, again, complex roots. And so you're asked to take a look at the graph. And for the distance learning module, I actually provided you with the graphs. And so if we look at what the graph of this looks like and how we could really generate this sketch, we would have done this if we were, not in the middle of a pandemic. Here I would, again, throw on that -1 that is one of my x-intercepts. As for the y-intercept, I know that the y-intercept is when the x values are 0. So the y-intercept here is actually at 1, right? So there's my y-intercept. I should label that this is the y-axis and this is the x-axis. And I know it's a cubic, and these are these non-real roots. Now it turns out, if you look at the technology here, that the turn of this non-real root happens actually at the real component, the -1/10. So the -1/10, by the way, is it's on this side of the y-axis. And so perhaps it will kind of look like this, where it comes up here, comes back down, and then comes back up. Now, you do not need to really understand where these turns happen, nor what is this real local maximum. You learn how to find these local maximum values versus the absolute maximum would be at positive infinity. But the local one right here, in calculus, we find out how do you figure out those values. But at least having some idea that the real part of a complex solution, the -1/10, is where that turn happens along the x-axis. Looking at polynomial 3 in this problem set, where you again now have a 4th degree polynomial because I have 2 quadratic factors. So I know right away that this will be a 4th degree polynomial. Because the a value here is 1, which is greater than 0, I know that this will open up. It will look like a W. And then how do I figure out these roots? Again, I have to think about, well, when is this quadratic factor equal to 0, and when is this quadratic factor also equal to 0? Looking at the first quadratic factor, it turns out I believe it's factorable. Does something multiply to -2 and add to 1? So 2 times 1 is 2. And if you make the negative with the 1, it will sum to a +1, but multiply to a -2. And so I could factor this to be x plus 2 times x minus 1 equals 0. And so -2 and +1 are two real roots of this fourth degree polynomial. As for these roots could possibly be complex, or they could be irrational, just that they're not an integer or a fractional value. So I'm going to use Che's quadratic formula. I guess I've been using that a lot. We'll go ahead and stick with that. So x equals -b plus or minus radical b squared minus 4ac all over 2a. And continuing to solve this -1 plus or minus radical. Well, this is 1 minus 4 and a -1. That actually turns into being 1 plus 4 or 5 underneath the radical, because again, this negative and this negative will make that a +4 and then all over 2. And so again, right here, I could simplify this a little bit to be the same thing as -1/2 plus or minus the square root of 5 over 2. I don't have to do that, but if you did it through completing the square, this is what your solution would have looked like. Whereas in quadratic formula, it's all over 2a, which is the same thing. So how do we plot these irrational roots? Well, we again plot the real ones pretty simply, but just by going ahead and throwing on those real values along the x-axis. We've got a value of -2. Maybe I'm going to scale this a little bit bigger. So I'm going to say at -2, there's a root. Also at 1, there is another real root. Now, how do we figure out where is the -1/2 plus or minus the square root of 5/2? I could also think about it up here as well. It doesn't really matter. What is the square root of 5? It's a little bit more than 2. Because the square root of 4 is 2, and 5 is a little bit bigger than that. So -1 plus about 2 is 1 over 2. What is 1 over 2? 1/2. So they'll be at about 1/2, maybe it's about 0.6. There'll be one of these x-intercepts, and the other one, -1 minus about 2, is -3/2, or -1.5. So this one will be a -1.5, or somewhere over here. And remember, it's a fourth degree polynomial. And so if these are my other roots, and it kind of comes down here, passes through there, before it comes down over here, and then passes on through. And so that would be the graph that would match. Again, I was just estimating about where those would be at. I hope that these videos have helped to support your learning of the content today.